Today we're going to look at solving some more advanced trig equations. Hopefully you were able to solve the ones from last night's homework without too much trouble. So today we're going to look at one more piece being added to that. But let's start by looking at an equation similar to one you looked at yesterday. So we're going to look at solving this equation 2 cosine x minus 1 equals 0. And we're going to look at solving it for x between 0 and 2 pi. Always it's good to think about, are we talking about degrees or radians? And in this case, whenever you see a 2 pi, unless it says otherwise, you can assume we're talking here about radians. Right? So this whole time we're going to think about radians. Now, there's a quick algebraic way to do it, and hopefully that's how you did it last night. But I want to think about the graph for just a second here. So if I were to graph y equals 2 cosine x minus 1, it's going to look like this. And because I'm looking for where it's equal to 0, then obviously that means where does it cross the x-axis? Where is the y value going to be 0? So I know I have two solutions. And so the whole point here now is I'm going to find those solutions. So you did this yesterday. If I start with this equation, then just go through like you would solve any linear equation, add 1, divide by 2, and we get cosine x equals 1/2. Hopefully you're pretty comfortable with this by now, that if cosine x equals 1/2, then x has got to be pi over 3. So if we think about that unit circle, x is pi over 3, which is right here. But now if we think about the cosine value of a function, remember the cosine value refers to the x coordinate. So that means that our other value is going to also be pi over 3, but it's going to be pi over 3 in the fourth quadrant because that's the other place that x is positive, which means we're going to be pi over 3 just short of 2 pi. So our final answer is going to be 5 pi over 3, meaning 1 pi over 3 less than 2 pi. And 2 pi is the same as 6 pi over 3. So 1 less than 6 pi over 3 would be 5 pi over 3. So those are our two answers. And this is our final answer for this problem. X is pi over 3 and 5 pi over 3, given our domain of 0 to 2 pi. All right, hopefully that's good. You did some problems like that yesterday. But now we're going to look at a similar problem to this, but now a little more advanced. So instead of looking at 2 cosine x minus 1 equals 0, now we're going to look at 2 cosine of 2x minus 1 equals 0. Okay? We're still going to look at it from 0 to 2 pi, but just take a second and think about what is this 2 on the inside of the function. What is it going to do to the equation? And the best way to think about that is think about the graph. What does the 2 do? Right? If you graph it, or if you think about this, then hopefully this is what you thought of. It actually is going to compress the graph by a factor of 2. So now this graph is squeezed together more frequently. So now if I look between 0 and 2 pi, now I don't have just 2 answers anymore, but you can see I have 4 answers because it got squeezed together by a factor of 2. So we're gonna solve that, and I'm going to talk about a way that we can sort of adjust for that in our solution. The first thing, though, we're gonna solve this just the way we did before. Our goal is to get cosine 2x alone on one side, everything else on the other. So add 1, divide by 2, and we end up with the same thing we did before. Cosine 2x equals 1/2. All right? And now we're going to solve for that. Now, the first two solutions should come pretty easily to you. They're the same as the ones we just looked at. That would mean that 2x is pi over 3, or possibly 5 pi over 3. But remember that this got squeezed together by a factor of 2, so we have to account for that somehow. So up here, we gave a domain as x is between 0 and 2 pi. But notice here, we're actually solving for 2x. So what we're going to say now, we're going to just kind of give ourselves a new domain here, and we're going to say, well, if x is between 0 and 2 pi, then 2x must be between 0 and 4 pi because we're just multiplying everything by 2. So that's our new domain. So now what we need to do is we need to think about all the values that are between 0 and 4 pi. So in addition to these two, we're going to go around the circle one more time. So going around the circle one more time just means adding 2 pi. If I add 2 pi to pi over 3, I'm going to get this answer here, which is 7 pi over 3, right? Just 2 pi is the same as saying 6 pi over 3, so add 6 pi over 3 to pi over 3, and you get 7 pi over 3. Same thing here, I'm going to add 2 pi to this, and I'm going to get my final answer, which is 11 pi over 3. Right? So those are my 4 answers, pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. But now I've got to do the last thing, which is convert it back to x. All right? Pretty easy. All I need to do is divide by 2, and I'm going to get my 4 answers. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right? So that's how I would solve a problem like this. Now I'm going to show you one more. What I would like you to do here is pause this now and try to solve this on your own before we go through it. Okay, so pause it here. See if you can solve square root of 2 sine 3x minus 1 equals 0. Again, we're going to look at the domain from 0 to 2 pi. All right, so pause it and try this. Okay, hopefully you tried this problem and it went okay, or you have a solution that you want to check against the solution here. Again, the first thing, always think about the number of solutions. If you graph it, or if you can picture this graph, the 3 on the inside is going to compress it by a factor of 3, which means we're going to have 3 times the answers we used to. So here we go now, 1, 2, 3, 4, 5, 6 answers for this problem. So you should have gotten 6 solutions when you solved it. The first thing, like we did before, is the algebra. So add 1, divide by root 2. Now remember that if I multiply 1 over root 2 by root 2 over root 2, that's just going to give me root 2 on top, and on the bottom it's going to give me root 4, which is just 2. So I end up with just root 2 over 2. So what I'm really solving here is sine 3x equals root 2 over 2. All right? Again, the first 2 values of this should come pretty quickly. Sine is a y value. So when we're thinking about the quadrants here, we're thinking about where is y positive, right? So 1 for sure is in the first quadrant at pi over 4. The second one, because it's a y value, then is going to be the other place where y is positive, which is the second quadrant. So pi over 4 short of 2 pi, which would then be 3 pi over 4. All right? But again, because we're not talking about x here, we're talking about 3x, then we need to change our domain. So we're going to say here, in this case, 0 is less than or equal to 3x, which is less than 6 pi, because we're multiplying everything by 3. So 2 times 3 gives us 6 pi. All right? So that means we're going to get our first 2 answers, pi over 4 and 3 pi over 4, but then we're going to have to keep going around the circle. So one more time around the circle will give us our next 2 answers, which are these 2, 9 pi over 4 and 11 pi over 4. That's to 4 pi, but I need to go to 6 pi, so I need to go one more full revolution. So I'm going to add 2 pi again, add 2 pi to 9 pi over 4, and I get 17 pi over 4. Add 2 pi to 11 pi over 4, and I get 19 pi over 4. So these are now my 6 answers. All right? But again, one more step here, which is I need to solve for x. So divide everything by 3, and I'm going to get my answers here. Pi over 12, 3 pi over 12, 9 pi over 12, 11 pi over 12, 17 pi over 12, and 19 pi over 12. The final step would just be to check if there's anything you can reduce, and in this case, there are 2 that we can reduce. Both of these I can, both of these I can reduce by dividing by 3, and when I do that, I get these 6 answers. Pi over 12 stays the same, 3 pi over 12 becomes pi over 4, 9 pi over 12 becomes 3 pi over 4, and the rest all stay the same. 11 pi over 12, 17 pi over 12, 19 pi over 12. Okay, good luck with the homework. There's just a few problems I'd like you to try. As always, email me if you have questions.